Welcome back. Building on our foundation in algebra, we now move to the second major math domain of the digital SAT, problem solving and data analysis. In our first math lecture, we focused on equations, variables, and linear relationships. In this lecture, we will study how mathematics is used to understand real-world situations. This domain focuses on data, ratios, rates, percentages, probability, and statistical reasoning. It is less about manipulating complicated symbols and more about using numbers to describe and analyze the world around us. These skills are valuable in science, technology, business, healthcare, education, and many other careers. Let us begin with proportional relationships. Many students think that a proportion is simply a problem where two fractions are set equal and then cross-multiplied. Cross-multiplication can be useful, but strong SAT students understand the relationship behind the numbers. A proportional relationship exists when two quantities change at a constant rate. For example, imagine that the total cost of an event depends on the number of participants. If the event costs £20 per person, the total cost increases by £20 each time another person joins. The number 20 is called the constant of proportionality. It connects the number of participants to the total cost. If 10 people attend, the cost is £200. If 50 people attend, the cost is £1,000. The numbers change, but the relationship remains constant. On the SAT, proportional reasoning often appears in ratio, rate, and unit conversion questions. You may be asked to convert miles per hour into feet per second. You may need to calculate the density of an object. You may also need to compare prices, distances, times, or quantities. The key is to treat units as part of the calculation. Units are not simply labels. They can be multiplied, divided, and cancelled in the same way as numbers. This process is called unit analysis. For example, suppose a car travels 60 miles in 2 hours. To find the average speed, divide 60 miles by 2 hours. The result is 30 miles per hour. The unit miles per hour tells us exactly what the number represents. Always include the units while solving the problems. They can help you decide whether you should multiply or divide. Now let us discuss percentages. Percentages are among the most common mathematical ideas in everyday life. We use them to calculate sales tax, tips, discounts, interest, growth, and loss of value. The SAT tests both basic and advanced percentage problems. A percentage means a quantity out of 100. For example, 20% means 20 out of 100. It can also be written as the decimal 0.2. However, the SAT often tests percentage change rather than a simple percentage of a number. Suppose a piece of equipment loses 36% of its value every year. A common mistake is to subtract 36 from the value. That is not correct. 36% is not a fixed amount. It is a portion of the current value. If the equipment loses 36%, it keeps 64% of its value. 64% written as a decimal is 0.64. Therefore, each year, the new value is 0.64 times the previous value. If the equipment is worth £1,000 today, its value after 1 year is £640. During the following year, the 36% decrease is calculated from £640, not from the original £1,000. This creates a multiplicative relationship. Understanding this idea will help you later when you study exponential growth and exponential decay. Remember this rule. A percentage increase or decrease is based on the original amount for that particular change. It is not usually a fixed number. Now let us move to multivariable thinking. In previous algebra lessons, we studied how one variable changes in relation to another variable. For example, we may study how the variable y changes when the variable x changes. In problem solving and data analysis, you may need to consider several factors at the same time. Imagine a study that examines how much sleep students receive. The study may not look only at the number of hours each student sleeps. It may also compare students by age, year group, study habits, or other characteristics. This means that you must examine the data in context. You may need to determine whether one group sleeps more than another group. You may need to decide whether the groups have similar averages but different levels of variation. This is why data representation is important. On the digital SAT, data may be presented in tables, scatterplots, dot plots, bar graphs, or box plots. You may be asked to compare the center of two data sets. The center is commonly measured using the mean or the median. The mean is calculated by adding all the values and dividing by the number of values. The median is the middle value when the numbers are placed in order. You may also be asked to compare the spread of the data. Spread tells us how far the values are distributed from one another. Common measures of spread include the range and standard deviation. The range is the difference between the highest value and the lowest value. Standard deviation measures how far the values tend to be from the mean. A smaller standard deviation means that the values are closer together. A larger standard deviation means that the values are more spread out. You do not normally need to calculate standard deviation by hand on the SAT. However, you must understand what it tells you about a data set. Now let us discuss probability and statistical inference. Probability is the study of uncertainty and random events. Suppose you flip a fair coin. You cannot know with certainty whether the next result will be heads or tails. However, if you flip the coin 1,000 times, you would expect the results to be roughly half heads and half tails. Probability does not always predict an individual result. Instead, it describes long-term patterns. A basic probability is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. For example, a standard 6-sided number cube has 6 possible outcomes. Only one side shows the number 4. Therefore, the probability of rolling a 4 is 1 out of 6. Statistical inference works in the opposite direction. Inference uses information from a sample to make a conclusion about a larger population. A population is the entire group we want to study. A sample is the smaller group from which we collect information. For example, a company may have 400 employees. It may survey 20 employees to learn how the entire workforce feels about a new policy. The 20 employees are the sample. The 400 employees are the population. However, the conclusion is only reliable if the sample represents the population. This is where random selection becomes important. A random sample gives every member of the population a fair chance of being selected. Suppose the company surveys only employees from one department. The results may not represent the entire company. That department may have different experiences from the other departments. However, if the 20 employees are randomly selected from across the company, the sample is more likely to represent the full workforce. When evaluating a study, ask these questions. How was the sample selected? Is the sample large enough? Does the sample represent the population? Was there any bias in the selection process? The SAT may ask which population a study can reasonably describe. The answer depends on how the sample was chosen. A random sample allows researchers to generalize results to the larger population from which the sample was selected. However, random selection does not automatically prove that one factor caused another factor. To establish cause and effect, researchers generally need a properly designed experiment with random assignment. This is an important distinction. Random selection helps researchers generalize from a sample to a population. Random assignment helps researchers determine whether a treatment caused a result. Now let us bring these ideas together. Success in problem solving and data analysis requires active thinking. When you see a graph, table, or word problem, do not immediately search for an answer choice that looks correct. First, ask what the data is showing. What quantities are being compared? What are the units? Is the relationship proportional? Is the change additive or multiplicative? Is the relationship linear or exponential? What does the mean or median tell us? How spread out are the values? Was the sample selected randomly? Does the evidence support the conclusion? Approach each problem like an investigator. Your job is not simply to calculate. Your job is to understand the situation and decide which mathematical tool is appropriate. Let us review the main ideas from this lecture. A proportional relationship has a constant rate of change between two quantities. Units should be treated as part of the calculation. Percentage change is multiplicative and is based on the relevant starting value. Data analysis involves comparing the center and spread of data sets. Probability describes patterns in random events. Statistical inference uses a sample to make conclusions about a population. Random selection supports generalization. Random assignment supports conclusions about cause and effect. The key idea from this lecture is simple. Do not look only at the numbers. Understand the relationship the numbers represent. In our next lesson, we will move into advanced math. We will apply these reasoning skills to nonlinear equations and functions. That completes this introduction to problem solving and data analysis.